This is Principles of Finance, Chapter 10, and we're going to be reviewing capital budgeting techniques. So, capital budgeting is the process of evaluating and selecting long-term investments. These investments must be consistent with the firm's goal of maximizing shareholder wealth. A capital expenditure is an outlay of funds that are expected to produce benefits for a period greater than 1 year. Fixed assets are considered capital expenditures. An operating expenditure is an outlay of funds by the firm that will result in benefits within 1 year. The capital budgeting process consists of 5 steps. First, a proposal must be generated. New investment projects must be proposed. Second, review and analysis. The merits of each investment must be analyzed. Third, decision making. Firms typically delegate capital expenditure decisions based on dollar limits. Fourth, implementation. Expenditures are made and projects are implemented. And fifth, follow-up. Results are monitored. Projects may be independent or mutually exclusive. If projects are independent, then that means that accepting one project does not eliminate the others from consideration. Mutually exclusive projects compete with one another. Accepting one eliminates others from consideration. So, examples of mutually exclusive projects. If a firm needs increased production capacity, they could have one of 3 options. They could expand their current plant, acquire another, or contract with another company. If they choose one of these 3 options, they automatically eliminate the others. Most firms operate under capital rationing. This is the financial situation where a firm only has a fixed number of dollars available for spending. Numerous projects are going to compete for these dollars. So they only choose projects that have the highest, most stable returns. Unlimited funding is the financial situation where a firm is able to accept all independent projects that provide an acceptable return. They have an unlimited amount of money. If a company has unlimited funding, they operate under an accept or reject approach. They evaluate capital expenditure proposals and determine whether or not they meet minimum acceptance criteria. If they meet the criteria, they accept. If they don't, they reject. Most companies use a ranking approach. This is where capital expenditures are ranked on the basis of some predetermined measure, such as rate of return. So they would rank projects based on their rate of return and only accept the highest. So we're going to look at some different capital budgeting techniques. First, we're going to look at how to analyze cash flows. So here, Bennett Company, they have 2 possible projects. First, Project A costs $42,000 and returns $14,000 a year for 5 years. Project B costs $45,000, returns $28,000 in year 1 and $12,000 in years 2 through 5. So we can put these on a timeline, just as we've done every other problem in this text. So Project A. At time period 0, Project A costs $42,000. That's a negative $42,000 for the company. And in periods 1 through 5, it returns $14,000. Project B at time period 0 costs $45,000. In year 1, it returns $28,000. And in years 2 through 5, in year 2 it returns $12,000, and in years 3 through 5 it returns $10,000 each year. So we've just created our timeline. We can use this to evaluate the project using several different techniques. The first that we're going to discuss is the most simple, and it's the payback period. The payback period is the amount of time required for a firm to recoup its initial investment. So the company will determine a maximum acceptable payback period. It's arbitrarily determined. There's no rules. And if the company is able to recoup its initial investment within that payback period, then they would accept. If they aren't able to recoup their initial investment within the maximum acceptable payback period, they would reject the project. So we can calculate the payback period for each of these projects. For Project A, calculating the payback period is very simple. Payback period for Project A is simply equal to the project's cost as an absolute value divided by the proceeds each year. We can calculate payback period in this manner because the cash flows received in each subsequent year are equal to one another. So $42,000 divided by $14,000 is 3 years. So it takes 3 years for the company to recoup its initial investment. Calculating the payback period for Project B is a tad bit more complicated. So calculating the payback for Project B, we start with the cost. Project B costs $45,000. We recoup $28,000 of this $45,000 in year 1. So we still have $17,000 left to recoup at the end of year 1. In year 2, we recoup $12,000 of our investment. So we still have $5,000 left. $5,000 is less than the $10,000 you receive in year 3, so you divide by the cash flows in year 3 to give you 0.5. So it takes 2.5 years to recoup your initial investment with Project B. So the payback period is 2.5 years. So you can see the payback method is very simple. It's computationally simple and very intuitive. It's often used by large firms to evaluate small projects and by small firms to evaluate most projects. By measuring how quickly the firm recovers its initial investment, the payback period gives implicit consideration to the timing of cash flows. But the payback period is usually used as a supplement to other decision techniques. The main problem with the payback period is that the maximum payback period is subjectively determined. The payback method is not based on the discounting cash flows to determine whether or not they add to the firm's value. A second weakness is that this approach does not take into account the time value of money. A third weakness is that the payback period does not take into account any cash flows that you receive after the payback period. So there may be a huge financial windfall at the end of the project's life, but that's not going to be included when calculating the payback period. So it's very easy to compute and very easy to understand, but it does have drawbacks. The primary benefit of using the payback method is that it allows you to use this in conjunction with more sophisticated techniques. So here, let's look at a few examples of why the payback period is not the best approach. First, we have Project Gold and Project Silver. Project Gold and Silver both cost $50,000. With Project Gold, you receive $5,000 in years 1 and 2 and $40,000 in year 3. So you recoup your entire investment in 3 years. With Project Silver, you receive $40,000 in year 1, $2,000 in year 2, and $8,000 in year 3. So it too has a payback period of 3 years. So both of these projects, according to the payback period, are equal to one another. The problem is that it's not giving any consideration to the timing of these cash flows. With Project Gold, you have to wait until the 3rd year to receive the $40,000. With Project Silver, you receive $40,000 right out of the gate. So it may make more sense to choose Project Silver over Project Gold, despite the payback period saying that the two projects are equal. A second problem. Here we have two projects, Projects X and Y. They both cost $10,000. Project X returns $5,000 in year 1 and 2. So the payback period for Project X is 2 years. 10,000 minus 5,000 minus 5,000. That's 2 years to recoup your initial investment. With Project Y, they receive $3,000 in year 1, $4,000 in year 2, and $3,000 in year 3. So $3,000 plus $4,000 plus $3,000 is $10,000. So it takes 3 years to recoup your initial investment with Project Y. So according to the payback period, Project X is better than Project Y. But when you look at this, Project X in years 4 and 5 is only returning $100, while Project Y is returning $4,000 and $3,000 respectively. So it's returning a significantly larger amount of money. And these overall magnitudes of cash flows are not considered. A more sophisticated measure is net present value. Here you subtract a project's initial cost from the present value of its cash inflows. So the net present value is equal to the present value of cash inflows minus the initial cost. This method is used by most large companies. It does take into account the time value of money. And the decision criteria is that if the net present value is greater than 0, we accept the project. If it's less than 0, we reject. So what that means is that if the net present value is greater than 0, the firm will earn a return greater than its cost of capital. It will increase the market value of the firm and increase the wealth of its owners. So using the same example, the Bennett Company, we can calculate the net present value. You've already used the net present value function on your calculator. Now we're just going to be including a cost. So we can use the NPV function on our calculator. First, we need to input the cash flows. Cash flows. To enter in these cash flows, you need to enter them into your cash flow worksheet. So when you push the cash flow button located next to the second button, it comes up and it says CF0. Previously, we always entered a zero in or skipped this function, but it's simply the cash flow at time period 0. Here, we do have a cash flow at time period 0, and remember this is a negative. So it's going to cost $42,000, so a negative $42,000. Push enter and the down arrow. Cash flow at time period 1 is $14,000. And here you can save yourself some effort by using the frequency button. The frequency of the first cash flow is 5. Alternatively, you could enter in $14,000 5 times. So you push the cash flow button. To clear out your cash flow worksheet, you push the cash flow button and then second and clear work. Cash flow at time period 0 is $42,000. Negative, enter. Down arrow. Cash flow at time period 1 is $14,000. Enter. Down arrow. The frequency of this cash flow is 5. Enter. Be sure and push enter after the last cash flow or it won't remember that you've entered it. Next, you push the NPV button and enter in a discount rate. Here we're assuming the discount rate is 10%. Enter. Down arrow. Compute. And you get $11,071. So this net present value is greater than 0, so if these projects are independent, project A would be accepted. Push the NPV button, enter in your discount rate of 10%, enter in the down arrow and compute, and we get NPV equal to $11,071.01. Remember the steps if you have a graphing calculator. NPV, the interest rate, comma, cash flow at time period 0, comma, cash flow at time period 1, cash flow at time period 1, 2, etc., separated by commas, close braces, comma, open braces, frequency of cash flow 1, frequency of cash flow 2, etc. So here it would be NPV, open parentheses 10, comma, negative 42,000, comma, open braces, 14,000, close braces, comma, open braces 5, close braces, close parentheses. And you should get $11,071.01. We can do the same thing for project B. The cash flow at time period 0 here is a negative 45,000. Cash flow at time period 1 is 28,000. That has a frequency of 1, so you can skip the frequency button. Cash flow 2 is 12,000, frequency of 1. And cash flow 3 is 10,000 with a frequency of 3. So push your cash flow button, second and clear work. 45,000 negative is the cost. Enter and down. Cash flow at time period 1 is 28,000. Enter. Down arrow. Frequency is 1, so down arrow. Cash flow 2 is 12,000. Enter. Down arrow. The frequency is 1, so down arrow. Cash flow 3 is 10,000. Enter. Down arrow, and the frequency of this cash flow is 3. Enter. Push NPV. Enter in your discount rates. Enter. Down. Compute. And you get $10,924.40. So if you have a graphing calculator for the second option, you do NPV 10, comma, negative 45,000, comma, braces 28,000, comma, 12,000, comma, 10,000, close braces, comma, open braces. The frequency of the first cash flow is 1. Frequency of the second cash flow is 1, comma, and the frequency of the third cash flow is 3. Close braces, close parentheses. I get so many questions because people forget to put the commas in. You do have to put commas between every cash flow and between the brackets and the interest rate. Once you have these entered incorrectly, you should get $10,924. If these projects are independent, then project B is acceptable because it has a net present value greater than 0. If these projects are not independent, meaning that they're mutually exclusive, by accepting one, you reject the other. Project A is better than project B because it has a higher net present value. $11,071 is greater than $10,924, so we would choose project A. So the rule is that if projects are independent, we accept projects if they have a net present value greater than 0. If they're mutually exclusive, we accept the project with the highest net present value. So the next method that we're going to use is the profitability index. The profitability index is equal to the present value of cash flows divided by the initial cost. The rule is that we accept projects that have a profitability index greater than 1. So the higher the profitability index, the higher the ranking. So there's one cheat way to calculate this. The profitability index, since you've already calculated net present value, is equal to net present value plus the absolute value of the project's cost divided by the project's cost. And again, here I like to put the cost in absolute values because when we think about this in a timeline, we usually consider cash outflows to be negative. So here we have our project A and project B, the same ones that we've been using. Remember, project A, the net present value was $11,071, and project B, the net present value was $10,924. So the profitability index for project A is equal to the net present value. Profitability index is equal to net present value plus the absolute value of the cost divided by the absolute value of the cost. So for project A, the profitability index is 11,071 plus the absolute value of the cost, so 42,000, divided by 42,000. So that gives us 53,071 divided by 42,000 to give us 1.26. Profitability index of project B is the net present value, 10,924, plus the cost of 45,000 over the cost of 45,000 to give you a profitability index of 1.24. So again, the rule is, if these are independent, you accept projects with a profitability index greater than 1. You can also use the profitability index to rank projects. So we would accept the project with the highest profitability index if they were mutually exclusive. So if we could only pick one of the two, we would accept the project with the highest profitability index, which is project A. Again, this is the same conclusion we got with net present value. Economic value added is a close cousin of net present value. It starts the same way as net present value. We calculate cash flows, but we subtract from those cash flows a charge that the investors demand on the project. So economic value added calculates the pure economic profit, the profit above and beyond the normal competitive rate of return in a line of business. So here we can calculate economic value added. Suppose the project costs $1 million. After that, it will generate cash inflows forever, perpetuity, remember that means forever, of $120,000. The firm's cost of capital is 10%, so we can calculate the NPV and the economic value added. Remember, NPV is the present value of cash inflows minus the cost. The present value of a perpetuity is its cash flow divided by the discount rate. And from this, we subtract the $1 million. So that gives us $1.2 million minus $1 million, so $200,000. You would accept the project. Economic value added. We have $120,000 that we receive every year. From that, we need to subtract the rate of return investors demand from their $1 million investment. They demand 10% of $1 million, so $100,000, so $20,000. So there's going to be economic value added of $20,000 per year. So it's going to be per year forever, so we can calculate the present value of these cash flows. So the economic value added for the project's entire life would be $20,000 divided by the discount rate, because again, this is a perpetuity, and the present value of a perpetuity is equal to its cash flow divided by its interest rate. So $200,000. So you get the same answer either way. But the economic value added tells you that this project earns more than its cost of capital each year, so it's worthy of pursuing. Another resource that we have is the internal rate of return. This is also a sophisticated technique, and it's the discount rate that causes the net present value to equal 0. So it's the rate of return a firm will earn if it invests in the project and receives the given cash inflows. The discount rate that causes the net present value to equal 0. So we simply take the cash flows and discount them by the internal rate of return and set that equal to the cost. And that is our methodology for calculating internal rate of return. It's very simple to do on your calculator, but the decision criteria is that if the internal rate of return is greater than the cost of capital, we accept the project. If it's less than the cost of capital, we reject the project. This guarantees that the firm will earn at least its required return. If the internal rate of return is greater than the cost of capital, the market value of the firm will increase, and so will the wealth of its shareholders. So the rule here, if the projects are independent, you accept all projects where the internal rate of return is greater than the cost of capital. If it's mutually exclusive, you accept the project with the highest internal rate of return, given that the internal rate of return is greater than the weighted average cost of capital. So we can calculate internal rates of return for our same example, project A and B for Bennett Company. To calculate internal rate of return on your calculator, you simply have to enter in the cash flows, just as we did previously. Cash flow at time period 0. A negative $42,000. Cash flow at time period 1 is $14,000 with a frequency of 5. Push the cash flow button. Clear your work. So 42,000 negative, enter in the down arrow. 14,000, enter, down arrow, frequency of 5, enter. Now you push the IRR button and compute. And you get 19.9%. Okay, so my PowerPoint stopped working. Give me just a moment. So the internal rate of return is 19.9%. We can do the same thing for our second project. The cash flow at time period 0 is a negative 45,000. Cash flow at time period 1 is 28,000. Cash flow at time period 2 is 12,000. Cash flow at time period 3 is 10,000 with a frequency of 3. So cash flow, clear your work. And you get 21.7%. So if you have a graphing calculator, you choose IRR, cash flow at time period 0, comma, braces, cash flow at time period 1, comma, cash flow at time period 2, comma, as many as there may be, close braces, comma, braces, frequency of the first cash flow, comma, frequency of the second, comma, etc., close braces, close parentheses. So for the second one, it would have been IRR, open parentheses, negative 45,000, comma, braces, 28,000, comma, 12,000, comma, 10,000, close braces, comma, open braces, 1, comma, 1, comma, 3, close braces, close parentheses. So remember the rule. If the internal rate of return is greater than the cost of capital, here our cost of capital has been 10%, then you accept the project. Both of these projects have internal rates of return greater than 10%, so if the projects are independent, you would accept both. If the projects are mutually exclusive, meaning you can only pick one of the two, then you would pick project B over project A because it has a higher internal rate of return. So one thing to note here is that using the internal rate of return methodology, you get a different result. Internal rate of return says that you should choose project B. Net present value said choose project A. So these conflicting rankings are not unusual. Oftentimes, the internal rate of return will rank projects differently than net present value. It will give the same accept or reject decision, but it may not rank projects in the same order. They do, however, reach the same conclusion about the acceptability or non-acceptability of projects. It's better to use net present value than internal rate of return. So here's an example to show you why. We have a 10% cost of capital. A large project costs $100,000 and returns $50,000 a year for 10 years. This large project has a positive net present value of $207,000. It has an internal rate of return of 49.1%, so it's acceptable. The small project, you invest $1 and earn 60 cents a year for 10 years. The small project has a very small net present value of $2.69, but the internal rate of return is 59.4%. So according to internal rate of return, you would accept the small project and forego the large. According to NPV, you would choose the large project and forego the small. Obviously, the large project would be superior to the small project. Here's an example. Tony is evaluating an investment opportunity. He feels this investment must earn 9%. The initial investment would be $7,500, and he would receive $500 a year for 4 years, $700 a year for the following 3. He plans to sell the investment at the end of year 8 and get $9,000. So we can determine whether or not this is acceptable. First, we need to put this into our cash flow worksheet. So at time period 0, Tony would spend $7,500. Time period 0, he's spending $7,500. He receives $500 a year for 4 years. For years 5 through 8, he's receiving $700. But in year 8, he's also going to sell the investment and receive $9,000. So if we were to put this in our cash flow worksheet, cash flow at time period 0 is a negative $7,500. Cash flow at time period 1 is $500 with a frequency of 4. Cash flow at time period 2 is $700 with a frequency of 3. And the cash flow at time period 3 would be $9,700. So if we use the IRR, push your cash flow, clear it out, 7,500 negative, enter down. Cash flow at time period 1 is 500 with a frequency of 4. Cash flow at time period 2 is 700 with a frequency of 3. And the third cash flow is 9,700. Enter. So push IRR and compute, and you get 9.54%. So because the 9.54%, the internal rate of return, is greater than the 9% he requires, you would accept the project. Greater than 9%, so you would accept. So if you had a graphing calculator, you would put this in as IRR, initial cost, negative 7,500, braces, 500, comma 700, comma 9,700, close braces, comma, open braces, frequency of 4, frequency of 3, frequency of 1, close braces, close parentheses. And you should get 9.54%. 9.54% is the interest rate that would cause the net present value to be equal to 0. Net present value profiles are graphs that depict the project's net present value for various discount rates. We can create these net present values for our chosen projects. So discount rates can be arbitrarily chosen. If you do them in Excel, you can start at 0% and work up by 0.5% all the way to 30%. It doesn't matter, just so long as you cover a wide range. Here we chose 19.9% and 21.7% because these were the internal rates of return for the projects. But again, if you were in Excel, it would not take any time at all to calculate the net present values for a wide range of discount rates simply by clicking and dragging. So here we can calculate net present values. All you have to do is enter in the cash flows into your cash flow worksheet, push NPV, enter in various discount rates, enter down and compute. So for example, for project A, you would enter in your cash flows. Cash flow at time period 0 is a negative $42,000. Cash flow at time period 1 is $14,000 with a frequency of 5. You push NPV, enter in a discount rate of 0, enter, down, and compute, and you'll get a net present value of $28,000. Now it's easiest to go through and calculate all of these at once for each project. So to calculate the net present value at 10% for project A, you simply push the net present value button, enter in 10, enter, down, and compute. And you'll get 11,071. At 19.9%, you get 0. That was the project's internal rate of return. Remember, the internal rate of return is the discount rate that causes the net present value to equal 0. And at 21.7%, you'll get a negative $1,650.46. So you can do the same thing for project B. You'll get 25,000, 10,924, 1,375, and 0. Then you graph these. Project A has a higher net present value if the cost of capital is less than the crossover rate. Project B has a higher net present value if the cost of capital is greater than the crossover rate. So these rankings can conflict because of differences in the magnitude and timing of cash flows. The primary cause of these conflicting rankings is the assumption concerning the reinvestment of intermediate cash inflows. So the cash flows that you receive in the middle of the project, so after you've already accepted it and before the project's over, those intermediate cash flows, the treatment of those is what causes the conflicting rankings. Net present value assumes that these intermediate cash flows are reinvested at the cost of capital. The internal rate of return assumes that they're reinvested at the internal rate of return. So it's more appropriate to assume that these intermediate cash flows are being reinvested at the cost of capital. It's not good to assume that they're going to be invested at the internal rate of return because this may be an extremely good project that may come about once every 20 years. So you may not have the ability to earn this great of a return later. So it's more appropriate to assume reinvestment at the cost of capital. So here's an example. We have a project that costs $170,000. It's going to return $52,000, $78,000, and $100,000. The net present value at 10% is $16,867, and the internal rate of return is 15%. So according to both NPV and IRR, this project is acceptable. So if we assume that these intermediate cash flows are going to be reinvested at the cost of capital, the future value of these cash flows would be $248,000. If they were reinvested at 15%, the internal rate of return, the future value would be $258,000. So you earn an extra $10,000 using the internal rate of return as the reinvestment rate, which may not be realistic. So we choose to use the net present value as our methodology of choice when the projects are mutually exclusive. If we looked at these as returns, we would see that choosing the reinvestment rate of 15% is going to give us a greater return than choosing the reinvestment rate of 10%. So another reason why internal rate of return and net present value may rank projects differently is because of the timing of these cash flows. When a large portion of the cash flows arrive early in a project's life, the NPV will not be particularly sensitive to the discount rate. The net present value of projects with cash flows that arrive later on in the project's life, however, will fluctuate more as the discount rate changes. The differences in the timing of cash flows between the two projects does not affect the ranking provided by the internal rate of return method. So here, if we're looking at the different projects again, according to internal rate of return, project B is always better than project A. If we use the net present value method, however, it says that project A is better when the discount rate is less than 10%. If the discount rate is greater than 10%, project B is better. So it's giving you a more accurate presentation of the data. On a purely theoretical basis, the net present value is better because it measures how much wealth a project creates. And there are certain mathematical properties that may cause a project to have multiple internal rates of return. More than one internal rate of return from a capital budgeting project will result when the cash flows follow a non-conventional pattern. The maximum number of internal rate of returns for a project is equal to the number of sign changes in its cash flows. So having a cost, a negative cash flow, followed by a series of positive cash flows, followed by another cost and more cash inflows is going to cause a situation where multiple internal rates of return can exist. Financial managers often prefer the internal rate of return simply because they prefer to work with rates. Another benefit of internal rate of return is that it does not require you to estimate the cost of capital prior to calculation. You don't have to enter in any discount rates to start with. You can calculate the internal rate of return and then compare that with the numbers that you calculate later with cost of capital. A scale problem occurs when two projects are very different in terms of how much money is required to invest in the project. In these cases, internal rate of return and net present value are again going to rank projects differently. Internal rate of return will favor small projects, and net present value will prefer the investments that make the most money. So in a recent survey, CFOs were asked to determine which methodology they use. They could pick multiple choices. 76% preferred, or 76% use IRR and 75% use net present value. There are also non-financial considerations to consider when choosing a project. For most companies, ethical considerations are primarily concerned with the reduction of potential risks. Another way to incorporate non-financial considerations into a capital project is to take into account the likely effect these decisions have on stakeholders. You could ask yourself, what are the potential risks to a company of unethical behaviors by employees? What are the potential risks to our stakeholders?